All right, so ladies and gentlemen, once again, I want to welcome all of you to the course for today. This is the basics of correlation and regression. It is something that will take us quite some time, about 1 whole month. We're going to be sleeping with correlation and regression. We're going to be eating with correlation and regression. We'll be dancing with it. It is probably the singular most, the broadest, the most expansive topic in the world of advanced quantitative research. So I want to do it in a very, very simple way for you to get it. Anytime you're undertaking a research project, a thesis, dissertations, depending on, anyone you know, as you start to do that, there will be that tendency. There will be the tendency for you to think about relationships. So there are so many relationships. For example, is there a connection between the Russian-Ukraine invasion? Is there a connection between that and fuel prices? Is there a connection? There is, isn't it? There is a connection between demand for wheat and the Ukraine war. There is a connection between higher amount of study and grade. There's a connection between smoking and cancer. There is a connection between several factors. So let's take blood pressure. Blood pressure is connected with age. It is correlated with stress. It is associated with diet. It is linked with exercise. And it is interconnected with several other factors. Now, the connection, is it linear or it is log linear or it is nonlinear? The connection, is it linear or is not linear? And what is the meaning of nonlinear and then linear? What assumptions must be in place for you to establish the connection very well? That's the essence of what we are going to do. We are going to look at causality and correlation. Correlation, please take note, if you are taking note. Correlation has to do with association between variables. The association between variables. Regression is the causality among variables, or the causality between variables. So whereas correlation deals with association, regression deals with causality, or causation. Let me just ask you to see whether you have an idea about this. You can raise your hand and tell me, what is the relationship between consumption and income? Is a relationship positive or it is negative? You can tell me. Between consumption and income. Kofi?
Please, there's a positive relationship between consumption and income.
Explain, Kofi.
What that means is that holding all other factors.
Explain again.
What it means is that holding other factors contra, the more income you earn, you're able to spend.
All right, okay. So, see, watch something. There is a correlation between consumption and income. It does not mean that income causes consumption to go up. No. Once you do that, you are establishing causality. But that's not what you got to establish. because consumption can also cause income to go up. If you have been consuming more, you may be willing to do more work and increase your income. So it's not one-way direction. That is why we focus on the relationship, the association, than establishing causality. What is the relationship between corporate social responsibility and financial performance? What is the relationship? What is the relationship? Boyson, CSR and performance. Boyson, CSR and performance. Sorry?
It's a positive relationship.
There is a positive relationship. Please note that by saying there's a positive relationship, he is not saying that CSR causes performance or performance causes CSR. No. What he's saying is that they are all positively related. When one is up, the likelihood is that the other is also up. It doesn't mean that one is necessarily causing the other to go up. Okay, so we are going to be doing a lot of correlational analysis, okay, as far as this topic is concerned. All right, let's start. So correlation deals with the association between two variables. Take note of that. The relationship between two variables. So let's take some examples. Correlation can be positive or negative, but it can also be strong or weak. Who can tell me this? The relationship between a brother and a sister, and then the relationship between cousins, which one is more likely to be strong? Generally, which is more likely to be strong? Richard?
So the relationship between brothers and sisters is stronger than between cousins.
Very good, generally speaking.
Yes, please.
So that relationship is said to be strong. So it means that some of you can have strong relationship with your spouses. You see, some of you can have strong relationships. Some of you will also have weak relationship with your spouses, with your partners. So correlation can be strong or weak, but it can also be negative or positive. What is the relationship between price and quantity demanded? Canton, what is the relationship between price, Emmanuel? Price and quantity. Emmanuel Martinson. All right, Ajua, what is the relationship?
Well, I think that it would be negative because the higher the price of something is,
Is it positive or negative?
Less of it that you're able to get.
Ajua, is it positive or negative?
Well, negative, sir.
All right, okay. The relationship between GPA and learning
sir.
hours.
Sorry, I don't know why you couldn't hear. Please, I said negative, sir. Hello, can you hear me, sir?
Okay, I got it. The relationship between GPA and learning hours. Is it positive or negative? GPA and learning hours. Isaac Abo.
Okay.
Isaac, GPA and learning hours. Okay, Abdul Malik, tell us.
Doc, please, ordinarily we expect a positive relationship between GPA and then learning hours.
All right, okay. So guys, that statement you are all making, it shows that you can have a strong positive and you can have a strong negative. And you can also have a weak positive and then a weak negative. But all of these things won't make sense unless you put a numerical value on it. So the numerical value assigned to quantify the relationship between two variables is known as a correlation coefficient. The correlation coefficient. Okay, there are quite a number of them, but the commonest one is known as the Pearson's product moment correlation coefficient. Pearson's product moment correlation coefficient. The correlation coefficient is between -1 and +1. If it is 0, it means that the relationship between the two variables are neutral. Please note, if you want to know whether the relationship is strong or is weak, it's not by the negative value. It is by the absolute value. So who can tell me this? Which of these show a strong relationship? Okay. I'm just going to write something. So you have -0.9 and then 0.86. Which one is showing a strong relationship? These two numbers. Which one is showing a strong relationship? Della?
So both are, but the 0.9 is stronger.
Okay, yeah. There are only two of them, and I only wanted you to tell me which one is stronger. So when you said both are, I was confused. All right. So 0.9 is stronger because the negative value is just showing the sign, the direction. It does not show the strength of the relationship. And please note, when we say something is negative, it doesn't mean that it is wrong. Okay? It is not moral negativity. Okay? So it's not negative as in bad. If you increase your price and I cut down my quantity demanded, that is a negative. That is not bad because I want to buy a cheaper good. So the negative does not show that the thing is bad. All right, at this stage, if you don't understand anything, raise your hand and let me be sure before I move on. Okay. All right. So let's get deeper. Let's get deeper. My focus is to let you understand correlation deeply. Okay. So there are different kinds of correlation. Now note that the Pearson's product moment correlation coefficient is a parametric. It's a parametric statistic. The Spearman's is a non-parametric statistic, and I'm sure by now you know the difference. So if the data is normally distributed, which one will you use? If the data is normally distributed, which one are you going to be using? Said?
So you use the Pearson product moment correlation coefficient, or you calculate that. Yeah.
That's it. So let's try to get a situation, a real life situation here. You are writing a journal paper, or you are writing your thesis. And the PhD thesis is made up of 3 different, papers, generally. In other words, we should be able to peel about 3 papers from the thesis. Question. Your thesis, this is a title. The title of your thesis is known as Determinants of Demand in the Alcoholic Beverage Industry in Ghana. Impact of Location, Occupation, and Religion. This is the title of your thesis. Now, why are you choosing this thesis? Because you have realized that previous studies on the subject exist. However, none of them have considered the potential effects of location and occupation. So sometimes, if you're writing the thesis, you need to get references to justify that point. Now, you may also have observed that whereas others have looked at the impact of religion on the demand for a particular product, and there are a few studies that are there that may have done that. So this is something you've combed the literature and you know it. And so you now say that none of them have included Buddhism as one of their religions in the analysis to the best of your knowledge. None of them have included Islam to the best of your knowledge. Okay? Maybe they've considered Christianity, but other religions are there. And so the essence of your thesis is to unveil those gaps. 1, gaps related to occupation. and location, okay? Because these have not been considered. And then gaps related to religion. Now, of course, these are called conceptual gaps. And in your thesis, you got to do that. You have to have theoretical gaps, conceptual gaps, methodological gaps, continental gaps, country gaps, industry gap. Okay? These are some of the gaps. Okay? You may have to have all of them or some of them, and then try to solve those gaps. This is what we call the problem statement. This is your problem statement. So the problem in this case is that they have not considered Buddhism. The problem is that they have not looked at these kinds of occupation. And yours is to get it. But that is not the only thing. These are called conceptual gaps. Okay? But there might be methodological gaps. For example, previous studies have used ANOVA. They have used Kruskal-Wallis, okay, and then T statistics to look at the relationships, okay, or the determinants of demand. But then you want to go ahead and use correlation and regression. That is a methodological gap that you want to fill in there. It can be a continental gap. And normally I don't buy continental. For PhD, it has to be stronger. It has to be theoretical, conceptual, methodological. Okay. But let me just mention continental gap. That must be an addendum, like it's been done in Europe, but it's not been done in Asia. It's been done in America, but it's not been done in South America. It's been done in America, South America, Europe, but little is known about the matter in Africa. You see the way it is. So in this way, you are identifying that there is a gap, a continental gap. Mm-hmm. Now, the lowest level of gap is when you look at country level gap. Okay. Country level gap is where you say that it's been done in US, Canada, Australia, okay, but it's not been done in Ghana. For me, that is not a big deal, but at least if you have evidence to prove that it's not been done in Ghana, or it's not been done in Nigeria, or it's not been done in South Africa, or it's not been done in India, if you believe that that could be an addendum, but not a major one. Emmanuel, you have a question? Emmanuel, do you have a question? All right, okay. So, guys, do you understand what I mean by gaps?
No.
Identification? Yes?
No, sorry, I think my...
Don't worry.
Can we have a regional gap? Now you mentioned continental, you mentioned country. Can you have a regional gap?
Yes, but again, at the PhD level, that is a bit of a big thing.
Okay.
But if you are doing a regional gap, then probably one of the things you've considered the conceptual or the methodological already, and the regional is just an extra gap you have identified. Yes, you can look at the northern part of the country, the southern part versus the eastern and then the western part. So most of the studies I know in China, they do provinces, okay? They do Wuhan province, okay? They do this province and then that province. So because it's quite big, that is great. But then that for PhD level, that must be an addendum to your main gap that you are filling. Do you get it?
Yes, please. Thank you very much.
Now, so you got to identify the gaps. And of course, from the gaps, you will get the contribution. You see, when you make your problem statement explicit, then your contribution becomes clearer. You got to be precise and concise. So the problem must be stated. So when you make a statement that majority of the studies have used ANOVA, they have used Kruskal-Wallis, they have used this, they have used that, but none of them have looked at using this method, maybe fractional systems regression model. Then you go ahead and justify why they should do that, or why you think that that one is better in addressing the issue. So when you are identifying the problem, you say that these people have used that, these people have used that, these people have used that, these people have used this method, but none of them has used this very method. And the reason why this method is important to be used is because of A, B, C, D. So now you stated the problem. What is your contribution? Your contribution becomes the purpose of my study is to contribute to the existing body of knowledge, okay, by using this method or extending this method or using this concept or adapting this method to this continent, to this country. And that way you will have a very powerful thesis that you are writing in that regard. Of course, from your review of the literature. Yes, Abdul Malik. Abdul Malik, your hand is up.
Question is, if you use the methodology, so I'm assuming that I go to one location, I pick participants, and I ask the question. And then I come to use 3 different methodologies to come out with the results. If I get different answers to what I'm seeking to do based on the different methodologies, how will that fit into knowledge contribution?
Beautiful, beautiful. Okay, so once again, it depends on, again, your goal you want to achieve. Okay, it's not all the time that when you use all the methodologies, you have to just apply all of them. Okay, sometimes you want to do methodological cross-checking. You want to use a particular method to corroborate another method. So if there are significant differences in the outcome, in the conclusion, I'm talking about the conclusion. So the numbers might be different, but the conclusions are the same. That is better, because that will mean that the methodologies are corroborating each other. Get a point? It's like traveling from the north to the south. You can use aeroplane, you can get there. You can use a car, you can get there. You can use a train, you can get there. Either way, you can get there. However, you'll be able to identify that aeroplane makes you get there faster. So the significance of the methodology, but it shouldn't be that you won't get there. Okay? So when you use a particular methodology and you won't get there, that is a serious problem. So in that case, that methodology must be chopped away because you got to get there. So they must lead to the same conclusion, but the differences has to do with, numerical significance between the methodologies. So yes, you can use methodology. If there are significant differences, you have to stick with the one that supports your original hypothesis or your original contribution or your original problem statement that you want to deal with. Abdul Malik, do you get it?
Yes, please. Thank you.
All right. So the next thing to do is to review the literature. Guys, when you are reviewing the literature, let me tell you some of the things you have to be careful about. The first thing to do when you are reviewing your literature is to create something called tabular taxonomy. Write it down, you will need it. Okay, every time you start your literature, whether it's your thesis, you're writing a paper or anything, have a clear-cut understanding of the tabular taxonomy. What is that? The tabular taxonomy is a kind of a table where you would have written the papers that have been written in the area of study. Again, these papers could be, you could categorize them along the lines. Okay. You could categorize them along the lines of methodology. So those that use a particular methodology against those that did not. You can categorize them according to the nature of the author. Okay. You can categorize them continentally, the number of samples. Okay. You can have a column for data collection, the data approach, the sampling approach that was used. You can have a column for the countries that were assessed. And then you can have a summary of the results. A summary of the results. So this tabular taxonomy, you got to be doing that every time you're reading around the papers. If you don't do that, you will not have a generalized idea of the area of specialization that people have already dealt with. And it's powerful. Don't underestimate tabular taxonomy. As you write a thesis, as you write a paper, as you write a journal article. Yes, Clement.
Yeah, Doc.
Yeah.
Hello, Doc.
Please go ahead.
I want to ask a question. Based on your explanation, what is the difference between the level of analysis gap and then the methodology gap? And then I want to also know, do we also have an organizational gap?
All right. Now let me answer the first one. Organizational gap, to be honest, again, the lower you come down, okay, that is where the issue is. But again, if you're going to have an organizational gap, okay, yes, you have. I call some of them industry. Within the industry, you can have an organizational gap. You can, but it must be stronger. Once again, it must be stronger. It must not be the ultimate. I've told you the ultimate. So if you have a particular conceptual gap and you want to apply it to a particular organization, okay, and that conceptual gap has not been used, now that conceptual gap is bigger, then, but because you're applying it for the first time in a different organization, it becomes an organizational gap for that. Because again, because the previous or the original tenet is that it is a new concept that you are introducing. Now let me go to your methodology and your analysis. Your methodology, you can use different methodology, and yes, you can make a methodological contribution or identify a methodological gap. So for example, a lot of the studies have been using a parametric test. Okay, so this is a methodological gap. And then now you develop a particular method. Methodological gap is not simple. Okay? I'm now developing a model, a technique. Okay? I'm developing a brand new technique, never used at all before in the world. Okay? I'm correcting a method that is already there. And now changing the way the authors looked at that method, and now developing a new method altogether. And then I will now go and take a new data set and apply the new method. First, I need to do simulation exercise to see whether it makes sense. Then I'll use a real data set to see that it makes practical sense. Now, that is a methodological gap you are filling. But along the line, I come to realize that the way the data is analyzed, for example, I'll give you an example. The way people used to analyze the data, they used to use something known as histogram, pie chart to do it, to showcase the picture and to bring home the point. But then you come to realize that no, that does not give you a better understanding of the density and the distribution. So you decide to use a kernel density estimation or violin plots. And this is very good. It doesn't just measure the central tendency. It also looks at the distribution, the variances, the dispersions, and it gets deeper and looks at other things. Okay, and this hasn't been used. So even in your graphical illustration of the work, you introduce new ways of picturesquing the work, and that becomes another, analytical contribution that you are making there, especially when you're able to make an argument for it. So yes, you can make a methodological contribution, and within the analysis, okay, you can make different other contributions as well in the analysis. Laman, do you get it?
Yeah, Doc, I got it.
Oh.
It's clear. Yeah.
So once you've gathered it, you're looked into the literature and you've gotten so much. And again, there is not a particular time limit as to how to go with the literature and how to go with the data. Some of them you could be doing overlapping. You could be collecting your data whilst you're also still looking into the literature and refining your problem statements. Okay. Now, for more steps on this, go to the MIT, Massachusetts Institute of Technology, and there are guidelines on how to write journal articles there. I'm telling you, read that document. I've also uploaded another document, which is how to write a research journal in a scientific journal, a research paper in a scientific journal. And you can look at that and read it and let it help you. Let me tell you one clue of writing. When you are writing, it's not simple. The most difficult aspect of the research process is the writing part. Like you are writing, it's tough. So learn the way others write. Okay, sometimes one way, especially if you're a beginner, one way is to look at the structure of how others have written, and then you work your own along a particular structure, maybe 3 or 4 or 5 papers. You have those papers there. You open them, you look at the structure, then you are combining the structural idea. You are working the structural idea into your thesis, into your paper that you are writing. Okay. But you got to read extensively. You got to read extensively to be able to know what others are saying. Sometimes you pick a paper and you see that a person has written 1 whole page without a reference. And you say, what? I want to do that. You can't do that. You have to start by giving references. You're a beginner. And because you're a beginner, you got to get used to giving references. You got to get used to giving the references after each 1 or 2 sentences. Okay? Because the people who are going to read will know that you are borrowing ideas, which is either an academic scholarship or even probably a plagiarism. All right. So get used to reading some of those papers. Now let's go back to our data collection. So you remember our thesis, you remember our topic. So what we've got to do now is to collect data. So we collected the data on some company, and the company is known as Burkutu Ventures. Now the company, Richmond, go ahead with the question. Richmond, go ahead.
Yes, please. With the literature review, looking at our thesis, is there a particular span of time? For instance, should we look at literature limited to 10 years, 20 years, which is more advisable? Because sometimes we hear supervisors saying that you don't have to use literature which is more than 10 years old. What is advisable, please?
All right. So generally, you use recent literature, but there are some statements and some methodologies that were published 30, 100 years ago. You can't say that because for example, suppose you are going to talk about a particular methodology. Okay. Let's say you are looking at a methodology in econometrics, and you are looking at a methodology which has to do with the 2nd stage regression analysis in a data envelopment analysis, 2nd stage regression. And you are trying to look at the various 2nd stage regressions that have been used to establish the relationship, what is known as the contextual variables, the impact of contextual variables on performance. And then the brains behind this are people like Simmer and Wilson. And you don't want to. And these people have published their paper, which is more than 10 years ago. Okay? We started with 2007. So if you look at the time now, 2007 is long ago. But you won't say that you can't reference them, because that is the methodology. They were the pioneers. Even if it's been revised, extended in any way, they are the pioneers. So you can't run away. So when something was promulgated or postulated or suggested or proposed by somebody, you can't ignore that and go and reference people that are borrowing ideas from that guy. However, when you're talking general terms, for example, you're talking and then you got to a point where you want to indicate papers. Papers that have used this methodology include, papers that have used this methodology include, that one you want to mention 2021, 2022 papers, 2020 papers. Okay? That is to show the power of what we are discussing in this regard. That is how you got to attack it. That is how you got to work it in that regard. But other than that, recent papers are always good. But if there's a particular method, concept, you can't ignore that. Even if it was published in 1913, you still have to bring it up.
Okay, thank you.
All right. So, Brukutu Ventures, they are concerned about the demand for the gym bitters. Demand in most of the retail shops has been hit. So, just a second, this company, so this is the demand for the shops, and management is concerned and they want to determine those independent variables that can better explain the quantity of gym bitters. Now, I'm giving you a storyline, but I'm going to go step by step. I'm going to use this whole story to teach you correlation and regression. Now, so the quantity demanded of gym bitters is affected by the price of gym bitters. It's also affected by several other factors. And you are told that some of the factors are the price of complement, the average real income of customers. Okay. In other words, the average income also affects the quantity demanded. So this is the data set. So you can see that the first column is the quantity demanded of gym bitters. The second is the price of gym bitters. Then you have the complement price, the income of the people in that shopping area. The demand is also affected by the location of the shop. And as you can see the location, there are two levels of this location. You have the urban and then you have the rural. That's the location. And then you have the occupation of the people also affect the results. Occupation affect the results. Okay. So once again, there are three kinds of occupation. There are levels of occupation. You have teaching, fishing, and trading. And then the demand is also affected by the religion. So you can see the nature of the data set. Now, who can tell me which variables are categorical and which variables are numerical? Which variables are categorical and which variables are numerical? Zaid. Which variables? Ben is Ajay.
Doc, I think the set of variables and then the third set of variables are categorical.
Okay. So those categorical variables are known as dummy variables. Dummy variables. We'll come back to that. Okay. So this is it. The instruction about the data is for you to know that a particular variable is a dummy. Location is a dummy. Look at the way it has been coded. The LU is 1 if the location is urban, or 0 if it is a rural area. Then the dominant occupation of the people. You can see that the dominant occupation are 3: teaching, fishing, training. And you have been told that OT is equal to 1 if the occupation is teaching, or 0 otherwise. OTR is 1 if the occupation is trading, or 0 otherwise. Now, do you realize that in all cases, one of the levels of the dummy is omitted? Do you realize that? So in the location, 1 was omitted. 1 was a 0 otherwise. Which one was that? Which one was a 0 otherwise in the first one? In the location. Which one was the 0? Yes, Isaac. Isaac. Yes, Said.
Rural. Location rural.
Yes. Now in the
non-urban center.
In the occupation, please just get used to raising your hand instead of talking in the air. Okay. In the occupation, which was the reference category? You see a word I've used. Which one was the reference category? Justice.
Dog fishing.
Fission. In religion, which was a reference category. Religion, which was a reference category. Zaid.
Buddhism.
Buddhism. Okay, so
Buddhism.
guys, watch something. The reference category is the one that is omitted. You don't actually mention it, but it is the one everybody else will be compared to. Take note. The reference category is the one every other category is referenced, is mentioned in reference to. So when I say urban, I'm talking about urban in relation to rural. But I want to, you not see rural in the list. You see urban. But when I say urban, I'm talking about urban relative to rural. If you look at occupation, one of them is what? Teaching. Teaching has been coded as one. And fishing is a reference category. That's why it's not mentioned. So anytime I talk about teaching, I'm talking about teaching relative to fishing. Anytime I talk about trading, I'm talking about trading relative to fishing. Take note. This is critical. When we come there, you see that it's critical. And this point is very, very important with several assignments you have. All right. Ladies and gentlemen, the first thing we want to do is to generate summary statistics and correlation matrix from this data. Summary statistics. So let's go to your data set and let's go and generate the summary statistic. We are going to do it in Excel first. So go to the Excel version of the data. So when you go to your data set, you will notice that the data sets have been grouped into two. Look at the sheet at the bottom. Do what I'll be doing. If you look at the sheet at the bottom, one sheet is known as Brukutu data, another sheet is known as Brukutu coded. We are using the Brukutu coded because Excel only listens and accept numbers. So we are using the one you have on your screen, Brukutu coded. Do you have that? Work along with me. We are going to generate the descriptive statistics right now. By the way, you should all know the descriptive statistics. Who can give me examples of descriptive statistics? Give me 2 examples of descriptive stats. Who can give me 2? Richard.
Say mean and median or standard deviation.
Yeah, very good, very good. Who can give me another one? I want some of the difficult ones. Isaac. Isaac, I think your microphone is not helpful. All right, let's go to Justice.
So ketosis and then median or the skewness.
Ketosis and skewness, very good. So we're going to generate them. Now in Excel first. So in Excel, go to the tab at the top called Data tab. Data tab. Okay. Data tab. You see Data tab at the top. Click on the Data tab. And when you click on the Data tab, you will notice that there's something on the right known as data analysis. Okay. Mine is not showing there. So if it is not showing, normally what it means is that if you don't see yours there, go to File, and then in the tab that will show, go to Options or Excel Options. Go to Options and Excel Options. Then when you open that, look for add-ins. And then in the add-ins, you will see Analysis 2-pack in the list. You will see Analysis 2-pack in the list. Click on it and come down to the bottom of the options pop-up. You will see Go. Come down, you will see Go, not OK, you will see Go. Click on Go. Click on Go. And then you see Analysis 2-pack. Tick it. There's a box to the left of it. Tick that box. Tick that box. Okay. So, and now when you do that, you will now be able to see your, data analysis at the data tab. Okay. You will be able to see it so nicely. So do that and then you'll see it. All right, so you see mine is showing on the far right, data analysis. Yours should be showing on the far right, data analysis. Click now on the data analysis. And you see in the list, descriptive statistics. It has been arranged in alphabetical order. You are looking for the one which is descriptive statistics. So double click it, and then a pop-up will show. I hope you are going along with me. A pop-up will show.
Doc, please,
Doc, I'm not.
some of us didn't get the data analysis, so yeah. Okay, I've got it.
All right. Now, the first pop-up, you see input range. Input range. Click inside the input range. The input range is requiring you to indicate where you want your results to be. That's all. It is asking you where you want the results to be. So while the cursor is blinking inside, click on J1. Click on cell J1. Those of you who have raised your hand, do you have a question?
Please, my internet went back, so I couldn't get the what we did. So I'm lost right now.
You should have raised your hand. That's
Doc, same here. Doc, same here.
Which is the same here? Farouk, ask a question.
It's not a question per se, sir, but it's just the steps. So you ask us to click on data, and then after that we got lost.
Say I got lost.
Got lost, sir.
So when you click on data, then in the list you see a pop-up will come. Then you double click descriptive statistics. Isaac, what's your question? Isaac. If you don't have a question, lower your hands, Farouk and Isaac. If you have a question, unmute yourself and ask. Yes, Caroline.
Yes, Prof. I'm using MacBook. So I saw analyze data at the top right. And when I clicked on it, a window dropped. And then I saw ask a question about your data. So I don't know whether I'm still on track or I'm actually lost.
Okay.
Okay. So you have to ask your MacBook how to get descriptive statistics.
Oh, okay. Thank you.
Chris, what's your question?
Okay.
Chris Atadika. Chris Atadika. All right, okay. Some of you are just raising your hand by heart. Okay. Just be careful and then.
Look, I'm so sorry. I have clicked on the data.
Please don't just interrupt me. You have to raise your hand, then I'll call you. Okay. It's very unprofessional. You guys know that. If you have a question, you have to raise your hand. Yeah, Richmond.
Yes, please. So I've clicked on the data, so I'm just asking where to go next.
Yeah, when you click on the data, then you look on the far right, you see data analysis.
Data analysis.
If you don't see the data analysis, it means that you have not invoked it. So go to your file on the top left.
Okay.
And then you click on that, and then you select options. Options.
Okay.
Options. And once you click on options, the parameter dialog box will come. It will show.
It's showing now.
Look in the list for add-ins on the far left flank. Add-ins. Add-ins.
Yes.
And then when you click on the add-ins on the right, you see analysis toolpath.
I have seen it.
Click it, come down, you will see go.
Okay.
Click the analysis toolpath, let it highlight blue. Then come down, you see go.
Okay.
G or go. And then when you do that, a pop-up will come. In that pop-up, there is a little box attached to the analysis toolpath. Take it.
I have.
Take it and click OK. You should be fine now.
Okay, thank you. I've seen it now. Thank you.
Okay, so now, once you are done, now you click data analysis. And then when this pop-up on the screen comes, you click the input range. And then inside the input range, just go and select one of the cells, which is J1, the one to the right of the RM column. I've already told you that the sheet we are working with is the Bluetooth coded. Okay, once you are done, take labels in first row. You see it in the pop-up here. Labels in first row. Then come down and choose output range. Yes, Bernice.
Hello, Doc, please. I don't really understand the input range. I don't know how we came about that. Is there any reason why we've chosen this so that in subsequent data packages, we will know why and what to type into the input range, please?
Okay, I've not even started. All right, so the input range, select it. Let me show you something. So the input range includes everything. So while the cursor is blinking in the input range, highlight everything. Those are your inputs. Highlight everything from K to RM. Highlight, drag it from the top to the down. All of them. Okay. When you exceed, come back. When you exceed, come back. And that will be collected in the input range. That will be collected in the input range. Okay, next question from John. John, what's your question? Abdul Basit.
Yes, Prof. After clicking J, please, I couldn't get the descriptive statistics. I don't know where to click again to get it.
Oh, but I'm not told you that you are going to get it.
Okay.
So you are only rushing. I'm saying that don't click J. I said go and highlight, click on the input range, the white space, delete that J, delete the J, and then go and highlight everything in the data.
Doc.
And this thing is freezing. Yes.
Please, I've done it up to where the data analysis is, but I don't know what you have said we should do again. And I'm not sure I'm following the subsequent
I'm saying that when you click data analysis,
yes,
and then a pop-up will come in the list, select descriptive statistics.
Okay.
Why are you guys taking us back like that? Select descriptive statistics. A pop-up will come. When that pop-up comes, you see input range. Inside the input range, go and highlight everything in the data set, everything from K to RM all the way down. Highlight and drag. Drag. Some of you don't know how to highlight and drag. And everything will be collected in the input range. So in the input range, you see A1 column I41. You see A1 column I41, all collected there. When you are done, take the next level, which is labels in first row. Labels in first row. And then when you are done, click the next one, which is output range. Output range. Once you click on output range, there's a white space to the right of output range. Click that white space. That white space will go and teach you where you want the results to be. I want the results to be in J1. So while the cursor is blinking in the white space of the output range, just click on J1. Once you are done, come down and take summary statistics. Summary statistics. You see it in the pop-up. Summary statistics. You are done. You are about to click OK, and your entire descriptive statistics must show. Okay. Your entire descriptive stars must show. All right. So that is it. You can see mine is showing here. Okay. And yours is also showing. And the whole thing has been highlighted gray. Okay. So you can see that for each variable, you have the mean. But this looks quite manya. So whilst it is still highlighted, go to the Home tab. Click on the Home tab.
Hello, Doc.
Yeah, you let me finish before you come take us back. Go to the Home tab. After clicking the Home tab, you will see General in the middle. I am clicking General, so you see something called General, a link called General, which is under the Home tab, just after Wrap Text and Merge Center. Click on that, select number instead of the General. Select number. The essence of that is to convert all of them to 2 decimal places. So once you click the number, all the numbers convert to 2 decimal places. Okay. Now at this stage, all of them have got a mean. So that is too much. So you want to remove some of the write-ups so that it looks nice. So the first thing you're going to do is this. You're going to highlight and copy the PCM, all of the top items. You got to be looking at mine as well. So select P, drag it all the way to RM. Copy. Actually, don't copy, cut. Cut. Control C to cut. And then come and click just the cell after the kill and paste it. Oh, sorry. Undo. Start from the kill rather. So pick the kill, cut it, and come to the next column to the right of kill, and then paste it. You just want the things to be under the numbers. The letters must have the numbers below them, not the way you have it. And since these things are all plenty, we want to delete some of them. So click on the mean, standard deviation, median. Control, click on the L, well, in my case here, I just want to delete this. So click on the L, Control, click on the N here, Control, keep your hand on Control and click on this and click on the R here. All the writings, we just want to clear them because there are too many. They are the same thing too. Okay. And just once you are done, right click and choose delete. And once you choose delete, all of them will go. Now the whole thing looks beautiful like this. Everything is well organized. Now, question. Who has the first question? Yes, Venice.
Okay, Doc. Please, with the output range, when I clicked on the J, I had J26. So I just wanted to be sure because yours was J1.
Yeah, it's because you have not dragged the thing up. You should drag it up.
I should drag it up.
Look at your Excel sheet. It must go up. You have to drag your screen to the top.
Yes. Okay.
All right, sorted. Let's go to the next person.
Thank you.
All right. So when you do that, you should be able to have this beautiful descriptive statistics for each variable. So on the basis of this, even in Excel, you can find the ketosis for each variable. Jewel.
Yeah, sorry, Doc. Just going back to the Excel, my network had cut out. So I was wondering, so with the output range, what shall we put in there? So I have J1 to I-41, but I don't think that's correct.
The output range has done what?
No, what should be in the output range?
In the cell. And I say you can choose the cell
J1.
J1. It's only to pinpoint where you want the results to be.
Okay.
All right, any other questions? So now you can do descriptive statistics in Excel. It should never happen that you don't know how to do descriptive stats in Excel ever again. From now on, you should be able to do it on your own. But we have not done it in R. So we're going to do it in R. So let's go to R. Go to your R command. After your heading, we are going to type the name of the data. And then we'll bring the data to R. Remember, anytime you want to work in R, you have to give a command for the name of the data. So we want to call the name of the data Jin, because this is Burkutu Jin Bitters. So just want to call it Jin, all small letters, J-I-N, type as a type. J-I-N equal to read dot the lane into brackets, double apostrophe, clipboard. So just as I have typed it, I'm going to do that. So once you've done that, you go back to your Excel. Go to your Excel. This time, you are not going to use the coded data. Look at the sheet. You are not going to use the coded sheet. There's another sheet called what? You can tell me. What is another sheet there? What was it? Richard, what's another sheet there?
It says Brukutu data.
Good. So that's the one we are going to select. So you pick on that Brukutu data. You can see that that one does not only have numbers, it also has categorical variables, not coded ones. So we're going to do that. We're going to take the data from here to Excel, from Excel to R. How do you do that? Just do Control A. That will highlight everything. Then do Control C. That will copy everything. Then you go to your R, where you have typed the command Jin. Whilst the cursor is blinking there, run it. How do you run? Control Enter or run. And once you do Control Enter, or you go and click Run at the top, you will see the name of the data showing down there, the name you give to it, Jin equal to blah, 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 blah. Do you all have it? If you have it, type Y. If you have done this and you have been able to bring it to R, type the letter Y. I want to be sure that you're on the path with me, because it is when I know that you are on, I move on. If you have not done it, type no, N for no. That way, so your data is inside. Now, you will not know whether you are right or wrong, except when you go and highlight the data. So go and highlight the Jin. the gene command, just as I am highlighting. Highlight it and run it. Just the gene alone or gene alone, and then run that one alone. Once you do that, you see the data now popping in the console down there. Beautifully popping in the console. Now, some of you are saying no, and I know part of the reason why you are saying no is because you have not been with us from the beginning. And some of you are now even looking for the data and all that. Okay. So let's work, those of you who are actually fully working with us. So you should have the data set showing down there in the console like I have. Please note, you have a big assignment where you do all of these things I'm doing. So it's important that you are on the same page with me. Okay. Now we have loaded the data set and we need to let R generate descriptive statistics. There are two approaches. The first is in the next line of command. Just type summary into bracket gene. I just did that. Summary into bracket gene. So you to do that and run it. I am doing that and I'm now running it. And down there in the console, you will notice that my results are showing. Summary into bracket gene. Now, if you check the variables that have been given here, you will notice that the minimum, first quartile, median, mean, all of these things, we've done it before. I just want to bring it here for a reason. The descriptive statistics or the summary stats have been given for all the variables except the last three. So if you check my last three, the length is 40, the class is character, the mode is character. Those ones, nothing was given. No summary statistics was given. Who can tell me why? Why is it that R is not giving us the summary stars for those? Justice.
Because they are dummy variables or categorical variables.
That is it. So guys, if you happen to get a dummy variable, sometimes you will not get a result. Now, if you happen to even get the summary, it will be meaningless. So don't read a lot of meanings into them. It should be meaningless. All right. Now that you've gotten the summary, I told you that there are two ways of dealing with that. The first way is the cheap information that we have here. Very cheap. There is a better approach of getting the summary statistics. To do that, you need to write a certain command. You need to require a command known as require psych. So you type require to bracket psych. And if your internet is good, whilst you are typing psych, it will pop. Require psych and run it. After typing require psych, then you type describe gene. Describe into bracket gene. So that describe gene is going to give you more descriptive stats than the summary gene. So when you run it, you will see it. You will see it all being given to you down there in the console. Now you can see that here there are more descriptive stats that are being given. The mean, the standard deviation, the trend, the maximum absolute deviation, the minimum, maximum, range, skewness, ketosis, standard error. All of them are being given to you. Look at the last three variables. Who can tell me why the last three variables are starred? Who can tell me why the last three variables are starred? Boyson.
Categorical variables. So the data is warning you that you can't explain it like the rest.
Perfect, perfect. So it shows that, so whatever number you are having there is meaningless. So that is very, very good. But these things we've done it before. So let's move on. Let's move on. So that is descriptive statistics. That is descriptive stats. Now, the next thing to do is some graphs. And I'm going to do just some few of the graphs. Yes, Richard, you have a question?
Yes, please. Concerning the question you just asked, could we also say that the 3 stars is because it has a significance level at 1%?
No, not at all.
Okay.
Yeah, not at all. All right. Kofi Odro, you have a question? All right, okay. So we are ready to do some graph, because sometimes you want to do an analysis of the data. You want to check whether a particular data is normally distributed. I know we have been using some other things. So I'm going to show you something very quickly. The first thing to do, and I want to put these graphs all together. The graph I'm about to do, I'm going to put all of them on one page. So, and you can command R to do that instead of splitting them. So we are going to take a command in R that will later help us to be able to put everything together. So just go to the next command and type the command known as pa-mfro. Pa-mfro. Okay, I'm typing it. Pa into brackets. P-A-R into brackets. mfro. Now, this mfro is simply indicating the number of graphs in the rows. And the number of graphs in the rows, we are going to make it 2 by, let's make it mfro equal to C into bracket 2 by 2. So just type what I've typed, I will explain. So what it means is that you want to draw a graph, and eventually you want the graph to be showing 4 items, 2 rows, 2 columns. That's what I've done there. 2 rows, 2 columns. So let's run that. Okay, 2 rows, 2 columns. I've just run that. And so now let's do the first graph. Now that I've indicated I want the graphs to be 2 rows, 2 columns, let's do the first graph. The first graph is going to be for quantity demanded of gin, for this data, quantity demanded of gin. We want to draw a histogram for the quantity demanded. That's what we want to do. We want to draw a histogram for the quantity demanded. So let's type hist. When you type H-I-S-T, histogram, okay, put into bracket quantity. And remember, the quantity is capital Q. So you do capital Q, and then you bring a comma. And then after the comma, you indicate the color. C-O-L is the color. Equal to double apostrophe. You can use any color. You can use red, blue, green, yellow, pink, and all of that. I just want to use red here. So I want R to draw a histogram of the quantity demanded for me. I want to have a look at how the histogram looks like for quantity demanded. And I want the color to be red. Okay, so I'm going to run that on the graph section. Okay. If you look on the right here, that's where the graphs will show on the plot. So I'm going to run that. And okay, he says kill not found. That's a good thing. Kill not found. Okay, so part of the reason why the kill is not found is because I have not attached it. So before this, after the path info, go and put a command and type attach gin. Attach into bracket gin. Okay, just enter and go and write detach into bracket gin, which means that when we finish everything, we'll detach it. So let's go and run the attach alone. Attach gin, run that. And now don't do the detach gin yet, and go and rerun the histogram. So sometimes you do your graph, you say, no, I didn't get it. And part of the reason why you didn't get it is because of some of these things. You didn't attach. So my histogram is showing here. You see that it has taken the top left of the graph because I have commanded it that all the next 4 graphs should be on one page. So you see that the first one is on this page. Let me see by hands, those, or by typing, yes. Type Y, those of you who have done this. Let me see, those of you who have done this, you type Y, let me see, I want to be sure. Some are following, and believe me, some will follow. Okay, fantastic. The next thing is to plot the density. Somebody says almost there, good. So let's go to density plot. So type plot into brackets. We are just trying to now do another graph. And that graph is, we're going to plot the density of price. So you type plot into brackets, density into bracket price. But the price is capital P, so note. And this density, you can bring, after the price, you can bring the comma and type color. Okay, COL equal to a different color. You can use a double apostrophe and type blue. So I want to plot that. Now the next graph will not vanish. It will still be here because you have already used the MF row to indicate that all the next 4 graphs should be on one page. So run that. And when you run that, you can see on the top right, the density of price is showing on the same page. The next graph I will finish will come down, bottom left. Okay. So we are just doing different graphings to have a feel of different plots that can be made. Okay. The next one, I want us to do the quantile normal probability plot. I want us to check whether the data Q is normally distributed using the quantile normal probability plot. Okay. The command is very interesting command. It is QQNorm. Type it as I type. It's QQNorm, bracket, capital Q, okay, then comma, you do your color. Color is equal to blue. So do that. All right, so the color is blue. The line width, we've gone through some of this. Is after the blue, step out of the double apostrophe. Then the line width, LWD, should be 4. You can change it in and out. Then that closes the bracket. Step out of the bracket, then bring your colon, semicolon. And then add the line. The line is known as a QQ line. Remember, it's a quantile normal probability line. QQ line. And the QQ line, you bring brackets, the same Q. Okay. And then you give it a color again for this. The first one, I gave it blue. The second one, I'm giving it a color of red. And then the line width for that. Okay. LWD is a line width equal to, I'm giving it a line width of 3. So when you run this, it will tell you whether the Q is normally distributed with a graph happening on the same page here. When you run that, as you can see in mine, you can see the normal quantile probably. Now the QQ line, oh, I made a mistake in the QQ line.
The color, there is no equal to after the color.
Yes. So color should be equal to red. That is why it's used this on blue. Okay. Now, because of the way I did it, the next color, the next thing has moved to the next page.